Alrighty, let's get going then. All right, yeah, so my name is Jared Watts, and I am a maintainer on two different open source projects that are heavily integrated into the Kubernetes ecosystem. And since this is an OpenShift meetup here, we will not shy away from diving into some of the Kubernetes internals maybe. And I think that this is a great format here to be as interactive as you guys want to be. Feel free to call out a question or voice your dissent on any of the slides coming up here. We can be super interactive and have a dialogue here. I'm happy to do that. All right, so let's go start talking about Rook now. So I don't know how many people have heard of Rook, but it is a project that was donated to the Cloud Native Computing Foundation, to the CNCF. So that was that foundation has a lot of the other projects in the ecosystem, including Kubernetes itself. Kubernetes was the first project hosted by the CNCF to graduate to full graduation. So it kind of fostered this big ecosystem for other projects based on Kubernetes and providing solutions in that space to hey Alex, it's good to see you. Good man, good. Thanks for showing up. So then that kind of gave a nice space for a lot of other projects to get off the ground and plug into that ecosystem. So when you want to answer the question of what is Rook, it's you can call it a cloud native storage orchestrator. And so what I mean by that is it takes Kubernetes and then it installs a bunch of custom controllers and custom types to do a whole bunch of automation for various storage solutions. So all these tasks here in this list that a human operator would do for a storage solution, Rook provides a framework and a set of controllers and types to bring all of those into the Kubernetes ecosystem. So it's an open source project, and it's completely community driven. So everything is up on GitHub, and the whole community is really open, transparent, and happy to talk to anybody at any time. So if we want to take a look at what storage for Kubernetes what it looked like in the beginning, is that what you'd normally end up having is you've got your Kubernetes cluster on the left there, and then normally what happens is that you have a set of a whole bunch of external storage services. Those could be a NAS device or cloud provider block storage like Amazon's EBS or whatever it may be. But the key here is that they lived outside of the Kubernetes cluster. So there are some various utilities or facilities that were built into Kubernetes by the storage group that enables these storage systems outside of the cluster to interact and provide storage for your pods that are running inside of the cluster. Through plugins and dynamic provisioning, things like that we'll get into later. But so having your storage outside of Kubernetes, it's got some advantages, but we're going to talk about what the challenges are here. So the first one is that it relies on that external storage being there, right? It's not portable. If you deploy your application into another Kubernetes cluster somewhere else, you might, you don't have that NAS box sitting there anymore, right? So those services, external storage services, have to be accessible wherever your Kubernetes cluster happens to be. They have to be rolled out. So that creates a bit of a burden too. So somebody has to manage them too. That you have these external storage services sitting somewhere. You get them set up, and then after that, somebody's got to end up managing them on day 2 and onward towards day in. And then also, the cloud provider managed services. Those are great because those, a whole team of engineers. DevOps, site reliability engineer, SRE people, they're running those for you. But when you start taking dependencies on managed services from cloud providers, you can get into a scenario of a vendor lock-in where it's hard to move and go to another provider. And we'll also talk about that later on for sure in depth. So here's another way to look at this. Instead of having storage outside of your Kubernetes cluster, one thing we could do is bring storage right on into the cluster. So, the Kubernetes as a container orchestrator is really good at providing a lot of facilities to automatically manage containers, the pods that the containers are running inside, handling errors, failovers, scheduling to different nodes on the cluster when nodes have a problem. So there's a whole lot of smarts inside of Kubernetes that we could take advantage of. We can harness that power for our storage systems as well. And so with these storage systems that we're deploying now inside of Kubernetes, we can write some intelligent software around those to use that power of Kubernetes to start managing it in an intelligent way. And we can provide some interesting abstractions to our storage too that make things more portable that once again we'll get into later. Kind of building up to everything here. So let's take a little review real quick about operators and custom resources in Kubernetes. So the operator pattern is, I first heard of it from CoreOS like a few years ago. And that was the first time I ever heard about the operator pattern. And now, it's integrated nicely after the acquisition of CoreOS to Red Hat. It's integrated nicely into that operator SDK and into OpenShift as well. But basically, when you're looking at what an operator is inside of Kubernetes, you can think of it as a piece of software that takes all of the smarts and the operational expertise, that domain knowledge of what it takes to run a piece of software, and then puts that into software itself. So you've got software that is looking and managing and configuring and handling errors, et cetera, tasks that a human would normally do. We're writing software to do that for us now. And so the basic premise of how an operator works is that it's just another form of a controller. A Kubernetes custom controller is the way you can think about it. And it sits in a loop that is constantly monitoring what the user wants the system to be and what the system actually is. So we call that observing, what is the current state of this cluster, and analyzing of how is that different from what the user said they wanted, and then act upon that cluster to perform some operations to always be driving what the actual state is towards what the user's desired state is. So a typical control loop, classic control loop. And then another thing a little bit of background information we need here is about custom resource definitions, or CRDs. These replaced third-party resources, I think maybe in Kubernetes 1.8, or maybe it was 1.7, but a few releases back at least. And this is Kubernetes extensibility story. This is how you teach Kubernetes about new arbitrary types. And the cool thing about those is that you can make them first-class citizens. So just like a pod or a config map or deployment or whatever that kube control knows about, you can make your own arbitrary types. The API server will know about it. You can perform actions on them. The kube control knows about it. So this is how we tell Kubernetes that some new software that we want to extend it with. And so the Rook operators. So we can look at Rook, the Rook project, as a set of a bunch of these operators and a bunch of these types for storage solutions specifically. So with these custom resources that Rook defines, we can capture the user's desired state for various storage solutions, like an object store or a distributed storage cluster or storage pool. And then the Rook operators will sit there and they'll run those reconciliation loops where they'll be watching for changes of what the user has specified. The user says, hey, I want this storage cluster. And then the operator will act upon what the user's desired state is to make the actual cluster match what the user has asked for with their desired state. And the operators, the way they're doing that is they're in constant communication with the Kubernetes API server, and they can use anything that the API server, all the resources it has, config maps and stateful sets or whatever it may be. And then the automated software of these operators can do interesting things like upgrade your storage system, or it can watch for health defects and monitoring alerts, rebalance data around the cluster. It can do also, these operators can basically do anything that we program to do, right? With the specific domain expertise of these storage systems. And so one important thing to note here, though, is that the Rook operators they're not on the data path. So when it comes to reading or writing bytes, like a file block, object storage, whatever it may be, when a pod that is consuming one of these storage systems that Rook has orchestrated for you, when you go to read or write bytes from it, it doesn't go through Rook then. It is speaking, that client there, or that pod there is going to be talking directly to the underlying storage system. And the operators, Rook operators, are merely just about setting them up, managing them over time, et cetera. So they can go, the Rook operators, you can shut them down, and you can still read and write bytes from the underlying storage system. So here's a bit of a busy slide about the architecture of Rook. And so let's work through this left to right. So on the left, we have kube control. And I don't know about you guys, but I was calling that kubectl for a long time until I was in the speaker lounge at, I think it was in KubeCon Europe last year in Copenhagen. And I heard a group of people from a company I'm not going to name, but I heard them making fun of people that call it kubectl. And my heart broke a little bit that day. And ever since then, I've been very, very dedicated to calling it kube control. So if you call it kubectl, I will not make fun of you because I've done it myself. So anywho, so on kube control, that's the command line Kubernetes tool that everyone knows and loves to manage their Kubernetes clusters. And so what this is saying is that on the command line there, through the custom resources that Rook installs, we get all these new types to interact with. So we get a storage cluster, a storage pool, file store, object store, all that sort of stuff that you can kube control create cluster. And so that is the users expressing their desired state of, I want a storage cluster. And so we see here that kube control talks to the Kubernetes API in the middle there. And everything is most things are kind of built there around the Kubernetes API server. So of course, the Kubernetes API server is persisting everything to etcd underneath. In the top right there, we've got the Rook operators. And so we're seeing here that the operators will sit there and they'll talk to Kubernetes API server, and they're going through their control loops, and they'll create pods, they'll create services, deployments, config maps, all that sort of stuff in service of fulfilling the user's desired storage requests. And so let's see, on the bottom right here, we have a set of daemons that run. So when you say, I want a storage cluster, you're specifying what type of storage cluster you want. It could be Ceph, MinIO, maybe you want a CockroachDB database, whatever storage it is that you want. When you've expressed that need for it, the Rook operators will deploy out the specific storage provider that you've requested, in containers or in pods, and all the Kubernetes primitives they need to run. Let's see, and then the Rook. You can look at the Rook agent and the Flex Volume plugin there. We can kind of gloss over that a bit because that's being replaced now by CSI, the Container Storage Interface, which is the new hotness for storage plugins that can be used across a lot of different container orchestrators such as Mesos and Docker Swarm and I think Cloud Foundry as well, and Kubernetes. So that as a storage plugin for when the user when a pod needs a block volume or a shared file system or an object storage, whatever it may be, the Rook agent comes into the picture there on the specific node that needs that block volume or needs that shared file system. But we won't spend too much time on that since it's being replaced with CSI. So let's put a little bit more visual here. So on the left is a Ceph cluster, CRD. This is a custom resource, an instance of the custom resource. So when the user says kube control create on that YAML on the left there, then the Rook operator is going to get a notification about that, and then it's going to speak to the Kubernetes API server to make sure that all the Ceph components get deployed out to the Kubernetes cluster and form a storage, a working distributed storage cluster. Are you all familiar with Ceph much, or? I know Alex is, and you're nodding your head. I'm not going to even ask you if you're familiar with, because you know everything. There's no point in asking you. But yeah, so Ceph is a distributed storage solution that I think it came out of a research project from the University of Santa Cruz, I think originally, and it's part of Red Hat now. And I have heard talk of it becoming the new OpenShift container storage instead of Gluster. I heard somebody say that, and I don't know if they knew what they were talking about or not, and so I'm kind of spreading rumors now that are unsubstantiated. But I did think that was interesting, though, that Ceph may replace Gluster for our OpenShift container storage. But anywho, the point is, though, that you have this YAML here that you're in a declarative fashion. You're saying, I want this a Ceph cluster, and the operators will use the Kubernetes API server to make that happen and bring up a Ceph cluster inside of your Kubernetes cluster. All right, so we're getting near the end of this talking here, and then we're going to give a demo which kind of brings a lot of this stuff together here, and then we can really start poking at it and asking questions. So in addition to these operators and these CRDs that we've been talking about for a bunch of different storage systems, you can also think of Rook as a framework too. So there's some libraries, some types, some testing, reusable testing patterns, et cetera, that different storage providers can take advantage of to make their job easier when they want to run inside of Kubernetes. So if you're a storage vendor and you want to run inside of Kubernetes, you could do all that stuff yourself, or you could take advantage of Rook's libraries and common specs and testing, automated testing frameworks and stuff like that to make that effort to get integrated into Kubernetes a little bit easier. So as we kind of already talked about before, the storage providers that have already integrated with Rook are Ceph, CockroachDB, MinIO. There's an NFS provider, Cassandra, Apache Cassandra is in there as well, and Nexenta EdgeFS is there as well, with hopefully more to come in the future as well. All right, so let's do a demo now, and I don't know what state I left this machine in. So let's bring up my Minikube. I better restore this snapshot, because God knows what I've done to it since then. So let's go ahead and start this VM. And this is a little Minikube. Do you guys run any Kubernetes on your laptops, on your developer laptops at all? And what do you use for that? Do you use Minikube as well, or? Yeah, Minikube. There's a contributor to the Rook project. He's actually a maintainer now, because he's been a contributor for quite a while. That he wrote a set of scripts that uses Vagrant to bring up any number of CoreOS VMs onto your laptop. So you can bring up 3 CoreOS VMs, and then it uses kubeadm to install Kubernetes cluster and get that running, so you can have a multi-node cluster running inside of your laptop. That is pretty good. It's a good solution. He's worked out a lot of the bugs in it, and he supports a number of other distros too. In addition to CoreOS, I think he does Fedora, he does Ubuntu. I think that's the 3 of them now. But it's pretty rad to, because I don't know of any other on your own machine be able to have multi-node Kubernetes clusters running, at least easily. So he's got a little make file that it's just make up, and it brings up lights up on all completely automated a multi-node Kubernetes cluster right on your laptop. Of course, that runs into memory issues real fast when you bring up multiple VMs inside your laptop. But yeah, it's pretty cool though. All right, so.
No, a Vagrant plugin does that.
A Vagrant plugin?
The YAML file that tells it, hey, I want these computers on these networks or whatever. It's pretty straightforward. You just do Vagrant group up, blah. It brings all machines up, and then you can read provisioning scripts for them.
Oh, cool. Does it bring up Kubernetes along with that as well, or do you have to provision?
You have to actually, put that in provisioning.
Oh, I see. Got it. Cool. Okay, so I think that, oh God, I've got to make this bigger. All right, let's make this. Let's see. Can we start reading that now? Kubernetes. All right, good. Excellent. Thought I dismissed this guy here. Go away. Okay. So we have I am not running a multi-node cluster, but I am running a Kubernetes cluster with a single node, the Minikube one, that's running v1.13. And let's kind of hop into this now. So this is my cheat sheet here, so I don't have to type because I cannot type and talk at the same time. I can't even click and talk at the same time. So I am going to start copying stuff from here. And oh man, I gotta make this one bigger too. Oh, that might be too big. I never like how when you start minimizing or decreasing the size of the fonts that it shrinks the window down. I just keep my window maximized, please. All right.
Do you have these in a gist or something?
These are all part of the Rook repo. So yeah, you can see all this stuff there. Some of these commands actually probably not because they're in the documentation, but they're not easy. I can just copy this right from here and have everything streamlined here with no help whatsoever. All right, so the first thing we're going to do here is that we are going to bring up the Ceph operator. So as we talked about before, the operators are the operators are those pieces of automated software that understand everything about a particular storage provider, and they're going to be sitting there waiting for you to ask for a storage pool or a storage cluster. And when we do that, they will act on that, and they will use all their automated knowledge of what a Ceph cluster is to bring up pods and things that are relevant for that. So we have the operators up and running right now. And then let's go ahead and create a cluster as well. So while that's running, we're going to see other things coming up here. But let's take a look at, man, I didn't make the font bigger for anything ahead of time. Sorry, guys. Boop, 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 boop. That might be a little too big. Yeah. So basically, the last command I ran was kube control create cluster.yaml. And so inside of cluster.yaml, we have some RBAC related stuff, service accounts and whatnot. But the meat of it here is that this custom resource of a Ceph cluster, we have some configuration information. Now this is just a sample YAML that has a whole bunch of comments, like documenting what the fields are. So there's a whole bunch of green stuff on here that's just comments. But basically, this gives you the ability to configure the way that you want your Ceph cluster to run. You can say what specific version of Ceph you want it to run for the daemons, like the monitors, the OSDs, the managers, etc. You can say how many monitors you want it to run, whether or not you want the Ceph dashboard to get enabled and run as well, some other stuff, and you want to get to something important. So the storage node here. So this is how you would be able to say what parts of your Kubernetes cluster's resources you want to be included as storage resources inside of the Ceph cluster. So right here, what I have is to say use all the nodes in the cluster. So every single node you find in my one node cluster, please use them. And don't use all the devices. If I said true there, I could it'll try to find every single free open device that doesn't have any partitions, doesn't have any file systems that it's found, doesn't have labels and maybe as well too, but devices that it thinks it can use that are raw and ready to go. Or you could specify a filter of saying, hey, every device that SDA on every node, whatever it may be, this is the way that you pass or you specify what devices in the on your Kubernetes nodes that we can give to Ceph to create a storage cluster out of itself. Cool. So I'm gonna make this a little bit bigger so it doesn't wrap. There we go. That's a little better for me at least. So what we have now here is the operators are running on the top there in the Rook Ceph system namespace, and then in Rook Ceph namespace we have a number of different pods here, and those are the pods that represent or make up what a Ceph cluster is. We've got managers, monitors, OSDs, so we have a fully functional Ceph cluster now with basically just, I guess, two commands. One command to kube control start the operators, and another command to kube control create the cluster. And since our operator has, it's a set of automated software that knows how to create a Ceph cluster using the Kubernetes API, we're done. We have it. It's ready. So let's use this software for something useful. So I'm going to go ahead and create a storage class. And I'm also going to create a little toolbox so that I can check on the health of the Ceph cluster easily on the command line. And this is what I wanted to see, that all the placement groups inside of that storage cluster are active and clean. None of them are damaged or unknown or anything like that. So that's good. And the next thing that I want to do is I want to run a little demo here that does something useful. So what I'm going to do is I am going to create an app that's going to consume this storage. And there's going to be a whole lot of things that happen underneath the covers here that we can kind of talk through once we get it running. So basically, the first thing I did is I started MySQL. And then I'm also going to start WordPress that will use MySQL. So WordPress is a stateful app. It stores things inside of MySQL to, like all the comments and posts, blog posts, etc., get stored inside of MySQL. So what we have running here now are two pods, one for WordPress and one for WordPress's MySQL database. Now what's interesting here is that the storage, the volumes for those pods are actually being dynamically provisioned and provided from our Ceph cluster that we created. So we have given the pods running inside our Kubernetes cluster, we've given it storage resources dynamically on the fly from a set of Kubernetes pods that we created with 2 commands. So let's bring up WordPress and let's configure it, and then we're going to do some other stuff while we're talking through it. So I am going to run this command just to get the IP address of the WordPress front end, which is here. That's good. And I'm going to use a super secure password of test. I like how they have a checkbox that you have to confirm your use of a weak password. Very weak. I like that. So it's going to do it. It's going to install some of the WordPress packages and stuff, which takes just a couple seconds. But let's maybe walk through what happened here to get this storage provided. So okay, so let's start with MySQL. So for MySQL, what we actually said here inside of the definition of MySQL, we said we created a persistent volume claim. And so I'm not sure how familiar everyone is with persistent volume claims and persistent volumes and storage classes, et cetera, in Kubernetes. But basically, a PVC, a persistent volume claim, is a request for storage. And so inside this PVC, I just declared it as 2 gigs because I obviously don't need a lot to just run a single blog with no content right now. But the interesting part here is that as its storage class, the blueprint for how this storage is going to be provided is coming from a storage class called Rook Ceph block. And let me bring that up real quick and hide this. Storage class. And so inside the storage class, this is what as an administrator, we create to basically provide the blueprint for how the storage is going to be provided. So as its provisioner, so who inside the Kubernetes cluster here is going to provide this storage that MySQL is requesting? And that's going to be Ceph coming from Rook and the block volume provisioner. And what pool should it use? It's going to use this storage pool that we had created, what namespace it's going to run in, what file system to format on there. And so basically, from our MySQL deployment, we specified, give me 2 gigs from Rook, please. And so now, what happens under the covers is that we see the MySQL pod is scheduled to run on a node in the cluster. That happens to be our only node in the cluster, so it's running on Minikube. But now when the Kubernetes scheduler picks the node that pod is going to run on, a little dynamic provisioning of the storage dance occurs here. And so on that node, the Rook storage plugin, or the CSI plugin in the future, it gets a notification saying there's a pod with this ID that needs this many gigs of storage and it needs this type of file system on it. And so on that node, running locally there, that Rook plugin first creates a block image in the cluster that'll serve as the backing store for those 2 gigs striped across all the nodes in the cluster. And then it maps that block volume image to a block volume device on the node. So it's like /dev/rbd 0. So it makes it a local device. And then it formats that local device and with the XFS or ext4 or whatever file system on top of it. And then it hands it off to Kubernetes saying, here's the path where you can find that 2 gig volume that you requested. And then Kubernetes takes, attaches that as a volume mount to that pod there. So underneath, so what we have is we have the MySQL pod, the container running inside the pod, that is talking to or mounted to a file system that the Rook agent provided, and which is backed by a Ceph block device, which is backed by a Ceph virtual image striped across the entire cluster. So there's a whole little stack there, turtles all the way down, of how we get storage that's distributed across all the machines in the cluster as a block device for one particular node.
Animation would be good at that.
That would be good. Yeah, my hand that's the animation there. Okay, so let's look at WordPress and then let's do something which demonstrates why this is kind of interesting. I hope that is the right credentials. I can't possibly remember a 4-character password. All right, so we have WordPress up and running, and it's persisted, in the MySQL database, which is backed by a Ceph block device. So let's add a reply here of hello London OpenShift. And I don't know how many times when you guys type OpenShift, you accidentally leave out the F. That happens to me way more often than I'd like to admit. So we won't use numbers here. All right, so we have on this Hello World blog post here, we've got a comment from me. And now let's do something a little bit crazy. So this command that I'm about to execute here, let's give some space to ourselves. What this command is going to do is it's going to go shoot the MySQL database in the head and kill that pod. So when we execute this, we should see MySQL here terminating and a new MySQL instance being brought up to replace it. And so this is really, what this is doing is this is demonstrating the dynamically orchestrated, self-healing, automated, benefits and functionality of a Kubernetes cluster. Kubernetes, does such a good job because it's so resilient. Everything, all these operators and these controllers are, always running and monitoring everything, so that, oh gosh, MySQL's down, and you said you want one MySQL running. I'm going to bring MySQL back up. Now, to do that, though, obviously in this case, since we're only running on one node, it doesn't apply here. But when you have a multi-node cluster, you might have to move that storage volume to another node, right? So the interesting thing, though, is that that storage volume is backed by the distributed storage system that's in our cluster. And so it's a very quick operation to, on the node that MySQL was running on, to unmount the file system, to unmap or detach the device from the node, and then on the new node that MySQL is getting moved to, we do the same operation of mapping or attaching the block device, not formatting it because it's already got data on it, but making sure that that file system is ready to go for the new pod. So that's how we can, when pods are moving around in the cluster, we can make sure that their volumes that they're requested are always following them around, and it's a very quick operation. What this really kind of clicked for me when, gosh, who was it? It was someone from HBO when they were checking out Rook for the first time. They were doing a failover analysis of EBS volumes. And so they would kill one of their pods that was backed by an EBS volume. And the whole process of detaching the EBS volume and reattaching it on a new node in the cluster that the pod had moved to was on the order of, 10, 15 minutes or something like that. That meant that their database was down for multiple minutes. But then when you have this, dynamically provisioned and dynamically orchestrated system where everything is running in Kubernetes, it's seconds. It's only a couple seconds to fail over, and it's barely a blip on their monitoring instead of this massive gap of downtime. So that kind of clicked for me of, oh wow, Kubernetes, it really does have a lot of primitives and a lot of functionality and features to run a resilient data center. It's actually pretty awesome, and it's Google's infrastructure for the rest of us, right? It's pretty awesome. So let's prove that worked. So I can refresh the site, and the comment's still there, and then we can leave another comment and post it on there, and it's persisted to MySQL as well. So we killed MySQL. It could have moved to another node in the cluster. Its data is still available. It's persisted. It is only a second or two, which gives us a highly resilient, highly available, highly durable, all sorts of those wonderful adjectives of storage for stateful applications. And so I think that's the end of the demo for Ceph. And so that's kind of Rook in a nutshell there, where we have operators running, we have custom resources that kind of declare or capture different storage constructs that a user would want to create instances of and configure, and then those operators are watching, they see what the user wants, they drive the Kubernetes cluster always towards what the user wants by looking at the actual Kubernetes cluster state and continually performing operations to make it match the desired state of what the user wants. And in this way, we can provide storage in a number of different solutions, Apache Cassandra and Ceph and MinIO, CockroachDB, et cetera. But it's the same patterns all the way throughout all of those, where you have an operator running and you've got custom resources that teach Kubernetes about new types and stuff, and then expose that storage for the users to use in their pods and their applications. So I'll take a break here for questions or discussion about Rook here before we move on to anything else, if anybody has any thoughts.
If you use Rook, how would you do it? If you do it manually without using Rook, you'd have to configure all the safe stuff yourself?
Yeah, so the first time I used Ceph, before any of this code had been written, I personally walked through the configuration steps for deploying a Ceph cluster. And the amount of operations you have to perform is fairly intense, where you've got multiple different types of daemons that you're bringing up, monitors, managers, object storage daemons, and you have to set up the CephX authentication, create the key rings, get the monitors into quorum, distribute out the keyring, copy and paste it like SSH to other machines, install the Ceph package there, give it the right authentication, copy over your ceph.config file, make sure the right elements are in there. I don't want to say ungodly, that's not right. It is a high number of steps, manual steps to do that. There was an effort within the Ceph community to automate some of that in Kubernetes, but we eventually had made enough progress with the Rook project that the Ceph maintainers, the Ceph core team, is now part of the Rook project as well. Like Sage Will, the founder of Ceph, is one of the Rook core contributors now, and Sebastian Hahn. A bunch of those guys now contributed to Rook specifically, and I'm really happy about that because we have Red Hat's backing for the Rook project as well. The Red Hat is one of the top contributing organizations to the project now, and they have a maintainer as well on the project. But it also is the specific Ceph experts on it. And that was a really cool thing for me, where when I was trying to build a lot of this automation and some things were failing, or I had things I didn't understand about Ceph, I would go Google it, and a lot of the hits would be for a blog by Sebastian Hahn. And then when he started coming to be a contributor to the project, I was, that's the blog guy. He knows everything about Ceph. This is awesome. And I ran up to him at one of the KubeCons, and I think I scared him a little bit with my enthusiasm.
When would you use Ceph without Rook? Because it's done for like code.
Yeah, well, so yes, that's definitely a good question. And so there's, there are some situations where, running on bare metal or integrations with other. If you're not using Kubernetes, then that's a non-starter, because we have to have Kubernetes. We completely depend on Kubernetes. So if you're not a Kubernetes user, then you wouldn't use Rook at all. I guess that's the core of it. But then people that have, maybe it was 2 months ago or so, no, 3 months ago, we got the Ceph support declared stable now. So it's been it was about 2 years of in alpha and beta getting up to stable, where people were running it on production environments when we specifically said not to. So we got some good battle testing out of that, but it wasn't stable enough that we were comfortable saying use this in production. And so traditional Ceph environments and deployments and tools would be the way to go for a lot of the bigger deployments. I know CERN runs I don't know how many petabytes it is cluster. It might be even to X, I don't know. But they run a massive Ceph cluster with thousands of nodes, and they're not using Rook for that. They're still using their traditional hand-rolled, manual deployed cluster. I think they have used some tools, but they're not using Rook for that.
Is it mostly just? Is it typically like the Rails Upbound stuff when you use? Is it CFS support as well?
Yeah. So all the storage. So that's what I love about Ceph is that underneath it's object storage. That's how it's how everything is persisted amongst the cluster itself. But it surfaces block storage and files, shared file system CephFS as well, in addition to that object storage through RGW, Rados Gateway. But yes, so you could instead of saying how we in that storage class we said. Use the block provisioner here. Something you would do similar is you would say use file system instead. So you'd get CephFS instead of RBD. You'd get the shared file system instead. And where I've found a lot of people having success with that is in high performance compute scenarios or supercomputer clusters where they have a bunch of jobs that get deployed out to a cluster, and they need a shared file system that can be written to by multiple jobs running all in parallel. And I've seen a lot of success with that. That seems to be a common case for at least for the people I've run into for using CephFS.
Does it just so I guess you don't see the crush map or any of that sort of stuff. It's just managed by the cluster itself.
Yeah, that's a really good question. So the crush map. Rook creates a default crush map, and there is some configuration that you can put into the cluster.yaml like this location tag right here to influence some of the failure domains and some of the crush topology information. And it's fairly basic though. If you wanted to get into more granular crush map management, then all the Ceph tools are available to you. So inside the Rook container image, you can use any of the Ceph tools like the Crush tool or RBD or Rados Gateway Admin. Like all those tools are available there, so you can drop into one of the containers and do some manual management if you wanted to. There's nothing that's going to prevent you from doing that. But yeah, most of our use cases kind of streamline things to the point of simplicity and kind of hides abstract away some of those more difficult details for a Ceph cluster. So it's all about simplicity is really what we're going for.
Does it take account of things like availability zones or anything like that for feeding into the crush map, like node tagging, for example?
Yeah. So it takes the host name from the node that you're on and feeds that into the failure domain information and topology. But the only other place you could specify that sort of stuff is in the location fields of the cluster. So it's fairly primitive, I would say. Those are good. Those are informed questions. Those are good questions.
Sorry.
Yeah, sure.
How does Ceph connect to the cluster, and how does the failover happen? Is it iSCSI or Fuse, or what? Do you choose that, or?
So, for instance, when it's being exposed to a pod for consumption, or?
Yeah. So you have a sort of volume claim.
Yep.
That's placed on a class that sits on a pool. That pool is presented to a node, And you talked about failover, depresenting and representing. That depresentation, representation, is that iSCSI or is that a map? Or?
Yeah. So that's using the kernel module, the KRBD kernel module. So that is directly mapping. You're going through the kernel module to map the block image as a virtual or as a block device on the system. So it's not using iSCSI, it's not using Fuse, it's not using TCME runner or NBD or whatever the things that I'm not even sure if those are the right terminology that could be appropriate here. But it's going through the kernel module that knows how to speak directly, RBD protocol on the wire.
Okay.
Yeah. I think that the Ceph team, some of the Red Hat guys, I don't know if it's at the design stage right now or if it's an implementation already, but they were adding their own NFS support on it, I think backed by CephFS with using NFS Ganesha to have that be a presentation of storage as well on top of it. And I don't know if they were talking about bringing in iSCSI as a presentation as well. I know that I had done some work on that at a previous company I was at, but that never saw the light of day. So I don't know why I bother telling you that, because it doesn't do anybody any good. But yeah. Do you have another question then?
Yeah, sorry. In like a multi-node cluster, do you segregate out the networking and have a separate storage network for the Ceph replication in the background? Or?
Yeah, you obviously know a lot about Ceph, so I like that. You're asking a lot of questions that clearly show you've used Ceph before. So they're in the ceph.conf file. You can specify a particular network to use for the back-end traffic for like the object storage daemons to talk to each other and do replication and migration of placement groups and moving blobs around the cluster that way. And then you can have a separate front-end network where your clients like pods and command line tools that are consuming the storage they talk to. So it's separation of that traffic. And so you can do that because you can specify any ceph.conf configuration you want to. There's a way to inject that kind of stuff in there. And I think there's also, I may be misremembering this, but I think there's also a way through some configuration here to specify what network to use for the back end. Now the difficult part with that though is that we don't currently have any facilities to create those networks for you. Like you have to already have 2 networks available for the pod using whatever CNI plugin or maybe host networking or something. You have to do that part yourself. But if you have those 2 networks available, you can tell Rook to make the Ceph daemons use that in their ceph.conf. And there's actually one of the other providers, EdgeFS, from a company called Nexenta. They're actually the champions of supporting multi-homed network scenarios. And so they're going through some design work right now. And I would assume that it's well on its way because he told me he's planning on speaking about it at KubeCon Barcelona in 2 months. So I assume he's making progress on it, about how we can from a common provide a common implementation of being able to manage multiple network adapters and get those ready and usable for different storage providers that Rook supports, like EdgeFS, and then it would be available for Ceph as well. How that's going to be implemented, how it works under the covers, I do not know yet. And networking is not my strong suit. I do not have a strong background in networking. I admit that fully.
Yeah, because I guess, certainly in my experience, Kubernetes and OpenShift as well, multiple network interfaces are particularly friendly.
Yep, that's definitely true. Yeah, most scenarios I've ever used, it's just a single overlay network or pod network that's available, and that's all that I, as a Kubernetes consumer, end up having to worry about at all. Yeah. Whew. Any other questions about Rook and Ceph or any of the other storage providers?
Is Ceph your most commonly used one?
It is by far, because that was the first. We didn't support any other storage providers besides Ceph until KubeCon of last year in Copenhagen, which was May of 2018. So it hasn't even been a year that we've supported other storage providers. And in Ceph, we've supported since day one when we open sourced like 2.5 years ago. So Ceph is by far the most popular. It's the only one we've declared stable. The other ones are all alpha or beta declaration. And it's got by far the biggest user base and the most support for developers as well, because there's probably at least 15 or so contributors that are employed by Red Hat directly. So it gets a lot of support and a lot of love from a dev perspective as well. So it's definitely the most stable and feature rich as well.
So are other vendors coming to you, or are you approaching them?
Yeah, so it's a kind of half and half, honestly. As part of the initial effort, kind of a proof of concept to show that, hey, Rook is not just Ceph, it can do other storage providers as well. We took on, as the Rook team, took on some of that effort. So MinIO and CockroachDB, we did those initial implementations ourselves. And then other people, once that functionality for Rook to support multiple storage providers, other people started coming to us. And as the project grew in popularity as well, people started approaching us to get involved with it as well. And I'm hoping that the common functionality that helps all storage providers, I'd like to see that more fleshed out than it is right now. There's lots of things that we could do to make this, storage providers' jobs easier, and that hasn't gotten as much development love as I would have liked to recently. So I'd love to see more effort go into that to possibly bring in even more storage providers that, once that support is more robust. Something I'm kind of interested in hearing about tonight, honestly, too, if we have time for it and people want to hear about it, is about Storage OS. I've been curious about the architecture and how that fits in the Kubernetes ecosystem and all that. So if we have time tonight, that's something I would be interested in hearing about, since we have the founders of Storage OS here in the room. So that might be something interesting later on too. I will talk about Crossplane as well, the multi-cloud control plane. But if anybody wants to hear about Storage OS and Alex wants to talk, that might be kind of cool. Okay, so let's. If anybody has any other questions, speak up and holler, and we can keep this going interactively. But I have I have some more slides and talk about another project now too, and one that's newer. So I'm more excited about it, honestly. That I'm one of those people that gets distracted by new technology. I've been working on Rook for 2 years or more than 2 years, and the next project, Crossplane, has only been open source since December, a couple months ago. So I'm really excited about that one. And I'm noticing too. I notice this every time I talk. A lot of my time frames and milestones are based on KubeCons. I keep constantly saying, oh, read about KubeCon Copenhagen or KubeCon this one, Austin, Texas. And I don't know what that says about me, that a lot of milestones in my life are based on KubeCons. That I don't know how the rest of my family would feel about that. All right. Oh yeah, you want to let's totally take a break right now if you want to, but in between these. Yeah, I'm down. Let's do it. Let's get out of here and mingle and hang out for a bit. What time is it? Oh yeah. Oh wow.